Okay, so let's say that that's a hill. A projectile is any object or thing that is traveling at a velocity into free fall. Okay, so let me explain what I mean. There's a couple types of projectiles. There's one where you only have a horizontal displacement to start, and there's one where you have an X and Y both when you start. Here's what I mean. If I kick this ball straight horizontally, kick Steven's head straight horizontally, it will have a path that will look like that. Okay? Those are the easy types of projectiles. Different type of projectile. Put Steven's head in a cannon.
Why is this so? Wait, it's on video. Oh, he got this on video. What is that? That's cannon. That doesn't look like anything else. It's like Raymond's got that on video too. On video.
Nothing's on video. Nothing happened. Okay. Alright. Why does that stuff happen all the time? Wait. How that stuff happens? Okay, alright. So let me show you the difference between this. When I kick this head straight horizontally.
Oh, it just falls.
Okay? After I give it that initial boost, the only thing that's acting on it is what?
Gravity.
Gravity, and it's just straight down because there is no vertical motion when I kick it. Okay? But here, I have a horizontal component and a vertical component of my initial velocity. Okay? So the ones where you're shooting at an angle are going to be more difficult because you have to consider there's an X component of it and a Y component of your initial shot. But if I shoot it straight horizontally, the only thing that's going to happen after I kick it is it's going to keep going horizontally at that speed, but velocity is going to pull it down. So what I'm trying to say here is if I had a ball that I kicked perfectly horizontally, and I dropped another ball at the same height at the same time, they would land at the same time.
Like the bullet if I dropped.
So what I'm saying is, I think there's actually
It's so confusing. Even if you kick it really hard,
Really straight.
yeah, you can kick it as hard as you want horizontally,
So hard.
and it's going to hit the ground at the same time as if you just took it and dropped it.
In real
Because
life.
I feel like
Not a
the velocity.
Well, in a vacuum.
Oh.
Yep.
And that's like 0.0 seconds total.
Okay. Now, obviously, one is going to travel a lot further horizontally. The other one's just going to go straight down. Okay, but as soon as after I kick that ball, because my kick is only going to hit that for about what, a split second. And as soon as I let go, there's no force on that. Correct? Okay. So it has an initial velocity horizontally, but then after that, after the initial kick, what's the only thing acting on it? Gravity. Same thing as if I just dropped it. What's the only thing acting on it? Gravity. Okay? And so it's going to accelerate downward the same way. So now if I keep it at an angle, it would have to go up, slow down, come back down. You see how that's going to be a little bit different? There's a Y component initially. So it has to reverse the upward stuff before it does the downward stuff. Okay. Objects that are thrown or launched into the air are subject to gravity are called projectiles. That's what we call them. Okay? Assuming you're in a vacuum, your projectile motion will always be a parabolic motion. You guys know what a parabola is, right? Okay? Alright, so here is your example. Drop it, shoot it horizontally, it will land at the same time because it's accelerating towards the Earth at the same rate or same acceleration in both situations. I know, it's hard to believe, I get it. Because if you think about it, you got to break it up into an X and a Y part. There's a horizontal part and a vertical part. Okay? So yes, the horizontal, if it never hit the ground, this would keep going horizontally. Okay? But since technically the vertical component initially of that is the same as the vertical component initially of that, correct? They're both at the same plane and have a 0 vertical component right off the bat. Does that make sense when I say 0 vertical component? Now if I shot it at an angle, now do you see how I have a vertical component that gravity has to slow it down on its progression up and then, you know, speed it up on its way back down. Okay? Wow.
Motion describes the motion of objects that are in free fall but have an initial horizontal velocity. Both balls are released at the same time and fall with the same downward acceleration. The initial horizontal velocity of the yellow ball does not affect its vertical displacement.
Now, if I were to take and go from this point to this point, and from this point to this point, like just the vertical part, it would be the same distance it travels vertically. The only difference is there's a slight horizontal part that this does not have. Does that make sense? Yes. Okay, if you look at it, from here to here and from here to here vertically should be the same. From here to here vertically, from here to here vertically should be the same amount. Because the only thing acting on it is gravity. The only reason why this one goes horizontally is because I kicked it horizontally initially.
As the ball leaves the pitcher's hand, it has a constant horizontal velocity. The force of gravity acts on the ball and accelerates it downward, causing its vertical velocity to increase. The two motions cause the ball to move in a curved path, known as a parabola.
That's depressing.
This is a great example, actually, because I know she did not throw that ball very fast, right? Because if Bryce were to throw the baseball, is it eventually? Yes, it will eventually hit the ground, right? But if you have a larger horizontal component, like if you throw it horizontally faster, it's not that it's going to drop any faster or slower, but it's going to get further horizontally over that time period, just because it has a faster initial velocity that way. Okay, so if that girl were throwing the ball like that, and if Bryce were throwing the same ball from the same distance, as long as it was perfectly horizontal, they would both land at the same time. Bryce's ball would just go further horizontally.
So if there was a pitcher on a mound and threw a ball and then dropped one at the same time, they would still...
Assuming he threw it perfectly horizontally.
Yeah. Because the acceleration.
And assuming we're in a vacuum. Although,
Yeah.
if they're both baseballs, I don't think it would necessarily matter because air would affect. Well, no. Because
What's the point of the vacuum? Just that there's nothing outside.
so that there's no air that stops it. Because if I take two things and just drop them, some things have more air resistance, and so there's an upward force that slows it down more than other things. But if you just drop it in a vacuum, then there's nothing that affects it vertically, and so that
I say we go outside.
Air resistance changes the path of a projectile. When traveling through Earth's atmosphere, the projectile's path is not a parabola.
Yeah, so technically, if you're not in a vacuum, it's not a perfect parabola. But we're going to assume everything's in a vacuum. Cool? Alright, so to solve projectile problems, we're going to use some similar kinematic equations, okay, in the horizontal and vertical directions. note that when we're in projectile, we're assuming free fall, right? Free fall simply means that our vertical acceleration will always be what? Okay. Everyone's staring at him while he blows his nose. Oh. I don't know why. Everyone's like so enamored with him blowing. Am I that boring?
No, not all the time.
Okay? In the horizontal direction, the acceleration is 0 after you let go of the ball, or after the ball is kicked. The only time it's accelerating is when you kick it.
Oh, what in the world?
Why is everyone staring at me?
Alright, we're just going to do this. At this point, and I'm going to give you a few equations. I thought there was an equation. What is that? Do you have any equation on your note up to this point? No? Alright, I guess I got to give it to you. Good. Now, what we're going to do at this point is just take and shoot them straight horizontal. Now, if I could, like, roll this off and drop at the same time, which I can't, but it would be fairly close. No, that was bad. I let it go way too soon.
Do better, Kurt.
We'll do it until you get it straight. That was better.
Yeah.
Did it actually look like I dropped it at the same time? Really important here, though. Notice, initial vertical velocity is always what?
0.
So your VIY is 0. Always for horizontal projectiles.
That makes sense.
Your initial horizontal velocity will be your initial velocity. So your VI in horizontal velocity component problems, or projectile problems, will be your VX. You could say VXI if you wanted to. But
So the VIY is always 0 when it's vertical.
when you're doing horizontal projectiles.
Why would it not be gravity?
This is velocity.
Are we gonna do
Oh. Okay. Wow.
Today? No. Tomorrow? Yes. No. Monday? Yes. Okay? Then we'll do a lab where we actually use a projectile launcher.
Nice. I never got it.
projectiles?
Wait, we should be Nerf guys.
I got Nerf guns too.
Alright, problems. But before we do problems, I got a few equations to give.
What? Like we had Nerf battles. I thought I got it, but we put it in one game.
Do these go on our note card?
Yep, these will go in your note card. Chapter 3 has by far the most equations of all the chapters. Did you count so
Chapter 2.
I gotta see what you.
Oh wait, no, this is chapter 2.
Skip chapter 1. Alright, here is a really nice, simple equation. There's one. That's your x component projectile motion equation. And this is going to be whether you are doing it straight horizontal or with an angle.
Wait, what's VX then? VX is velocity.
Here's the x component of velocity.
Oh my word.
Remember I said, in horizontal projectile problems, your initial velocity is your Vx. Because if you're just shooting it straight horizontally, all of your initial is x, none of it is y. If that makes sense. Okay, so if I take a ball and I shoot it straight horizontally at 25 meters per second, the initial velocity is that, but all of that would be x direction. There would be, Vx would be 25, and your Vy would be 0. Because there's no vertical velocity when you kick it, or when you shoot it straight horizontally. Okay? A couple other equations. Assumptions?
Yeah. I'm saying like assuming you take the straight, that's what those.
Alright, so here's where we get crazy here. There's one. I'll explain what these things
like using X and Y for stuff. That's not fun. Why? Just do horizontal or vertical.
So I need to write horizontal or right vertical?
I mean, I guess.
Abbreviate.
V is already velocity.
Yeah.
What is V1 again?
Vy would be the y component of the velocity, and F there would be the final. For example, if I have an object and I'm shooting off a projectile and it goes like this, it would be your velocity right before it hits the ground.
What was that?
Your y component that's right before it hits the ground. Your x component should be the same as what it was when you let it go.
Why does this look I was about to say let it go right there, but it's not like this number.
It is. Guys, these are the same equations we used in chapter 2, last chapter.
Acceleration.
It's the same stuff, except for now I'm specifically saying this is y component.
Yeah, we don't have
That's
VI.
It is, yes. These are the exact same. This should look like a projectile, or not a projectile, free fall equation from last chapter. This should look like these all should look like free fall, because we're in free fall, right? But now we're in two-dimensional free fall. So we have to know x and y. Okay.
So on that one, is it your y acceleration times your y acceleration?
This one?
Yeah.
2 times acceleration in the y, which is always negative 9.81. Well, yeah, we're in free fall here. So guys, you realize that projectile motion is just a more complicated version of free fall. Because as soon as I kick that ball horizontally, right after I kick it horizontally, what's the only thing it's really just a free fall problem. It's just a free fall problem with an initial horizontal velocity versus a free fall problem where I start at rest and I drop it. Okay? And the same thing when you shoot it at an angle. It's still a free fall problem, but instead of just dropping it, I'm now shooting it up at an angle. So, still free fall, just a little more complicated because it's two-dimensional free fall. What was that? So this is y component final velocity of it going, in this case, any of these cases, probably downward. Okay. Well, this would be your initial for horizontal. Okay? Any questions so far as to what these equations are saying? Change in time, acceleration due to gravity, change in y. Why is that important? Well, there's going to be a lot of changing in y's in a free fall problem, right? Okay? So essentially these are all probably got derived from a very similar equation or two similar equations, and it's just solving for different variables, making it easy for you. Okay? Easier for you. I don't want to say easier. Okay? So, again, part of the struggle and part of the reason why the first initial chapters in physics are difficult, yes, is there some difficult math, but secondly, you've got to get good at drawing stuff, which we've come to realize that's not as easily done. Okay? So, here we go. Royal Gorge Bridge in Colorado rises 321 meters above the Arkansas River. Suppose you kick a rock.
George.
Horizontally off the bridge. The magnitude of the rock's horizontal displacement is 45 meters. Find the speed at which the rock was kicked.
So you solve it.
So let's draw a picture.
Y.
There's let's just do X, Y. I could do a couple things. I know, that's so hard to do.
There's a slant. You got the horizontal down.
Nice. Look at that.
That's good.
Why is it like a straight line?
Okay. So you could do this two ways, and it doesn't matter. You could say that you're kicking the ball from the origin, or you could say that you're kicking the ball from up here. For example, let me show you what it would look like. Right? This would look like this if I kick the ball from the origin. If I kicked it from up here, would it have the same pattern? Is it still going down? Even though I'm starting above, everything in the direction standpoint is down. Whether I start here or whether I start here. Make sense? Okay, let's use that one. Okay? So So, we got to write some things in here. We know how high this is, right?
Yeah.
321 meters.
I like that.
Everything's not your. Yes.
321 meters, and that would be my what? What is that from a variable standpoint? What was that? Change in y, yes. And typically that's negative, right?
Correct. Because it's falling down now.
Initial, final, direction is negative. Yeah?
Wait, why is it?
Because it's going start here and here.
Oh, okay.
Negative direction. Okay? What else did they give us?
Horizontal.
Change in X.
What's that?
No, let's just change X.
No, V, X, V, or VX.
Let's just change an x.
That's all.
They didn't give us any velocity things.
That's positive.
And that's going to be positive.
DIY.
We know AY.
Negative 9.81.
Yep.
And then something 0.
DIY.
Well, typically, when they want like the vertical velocity, they probably want it right before it comes to rest when it hits the ground. If that makes sense.
Yeah, not 0.
Because we know that when it hits the ground, it's 0. Right?
Can't hurt you right.
Okay, so here's some things we don't know. We don't know change in time. Is that what we're solving for? I don't know.
No.
And we don't know Vx. Remember, Vx and Vy are the same thing. Or not Vx and Vy. Vx and Vi are the same thing. Because my initial velocity is all x. Make sense? Straight horizontal, we're picking this. Okay?
Wait, so then why do you have both of them? Like, why don't you just do the same thing? Why don't you just get rid of one of them and always use the X?
Because when you do at an angle, like if I shoot it at an angle, and I say that that was shot at 25 meters per second, that is VI. I have to break it up into an XY
So it's just until you get
Yeah, it's just until you get to projectiles at an angle, we can assume that they're the
Well,
same.
even if it goes up and down, wouldn't VI still be wouldn't it be VY then? Not VX. If it was shot straight up.
If it was shot straight up, yes. We won't ever do one that's just shot straight. I don't think. I can't remember from things in the past that we have to do that. Okay. So we know we got a set of equations here. I can almost guarantee this is one we'll use. Okay, but we have two unknown variables in this equation, yeah?
Yeah.
Which means I have to have a second equation. For every variable you don't know, you need to have an equation, that many number of equations to solve the problem. Okay, because I'm going to have to substitute one variable out. Okay?
Where's speed?
We don't have any speed.
Well, it says
I
final.
don't know, like you can find
DYF
speed.
squared
Yes.
Wait, what's VY?
Vx equals Vi.
Or there's no speed.
Velocity speed.
Vx equals Vi.
Well,
Yeah, same idea.
Hey,
What's the matter?
what's VY at?
Final velocity in the y direction.
So we can use that.
Okay, so we need one of these other equations.
V.
And now, there's a bunch of equations. I gave you 3 other y equations, right?
Yeah.
Okay? But only one of them has all the variables we want with time in it.
It's the
Which one is it?
Change Y equals 1/2.
Yep. AY, or take a t squared. Do you see how we have change in y? We know the acceleration. We don't know time, so we can take and substitute time in for time to eliminate the time variable and left with just your Vx that you need. So I need to take both of these and solve for time. This one's easy. Yeah? That one's easy. Take and divide by Vx. This one, dividing by half is the same as multiplying by 2. So I'm going to divide by a half, and then I'm going to divide by my acceleration. That should give me change in t squared. To get rid of the square, that would do what? Everyone see what I did? Divided by a half, which is the same as multiplying by 2. Divided by acceleration due to gravity. Took the square root to get rid of time squared.
8.1.
What? No, okay. I wouldn't worry about that. I'm just going to substitute it. Are you something wrong?
No, I was.
Question?
Why would you need to do that top equation for solving for t if we were?
You don't, but you need this for to answer our actual question. So you could plug in all the numbers, plug it into t, plug it into here, solve. I'm going to do them all together so I can give you one equation that you're going to need.
Okay, I got it.
Okay? To make things easier, so you don't have to do this every single time. Cool? Cool with that?
So it's like a cheat sheet.
Well, I'm showing you how you would do it, but then I'm letting you use the easy way, unfortunately. This is what we were talking about this morning, about how I kind of think I should just not do that and make it all match.
Me doesn't like just plug it into
Okay, so I'm just going to replace change in t with change in t. And now I'm going to solve for what? What do I need to solve for? What am I solving for?
Shouldn't it be VXI
Technically, but because it's horizontal, projectiles, they're the same. So we're just going to assume that. Okay.
We can write x and y differently, like horizontal and vertical, instead of having x for displacement and x for horizontal.
If I have vx, it's referring to the velocity in the x direction. I think that's better.
If you divide by a square root, it's and fraction inside of the.
What I would do is I would take the reciprocal of both. Okay, so here's how I would do this. I would take the reciprocal of both, and then I would what? Multiply by change in x. Okay, so you should get this. The reciprocal of what I have here, ay over 2 change in y times change in x. So that's just essentially taking the reciprocal of both of these. So now Vx is on top, and then change in x would be on bottom, multiplying it over, and you should get this. This is an equation you're going to want to put in your note card. Okay, and then all you would need to do is plug in all the numbers and solve. We like it that way. It's not part of the square root. So you would do the square root first and then times it by the change in x. Why don't you guys solve?
Well, we don't have changes.
We don't need it. We took it out. That's what we did this. That's
So
what
we're
we did
doing
here.
that equation first and then the changes in the
You don't need the change in t. That's the whole point of getting this, is if you don't have change in t, you just use this equation. If I didn't give you this equation, you would have to plug in, find change in t, which was originally here, then take that number, plug it in for change in t there, and solve for your Vx. And then using one equation
5.56.
Is AY always thinking that?
5.57
for free flow.
5 point.
But we'll never use it for.
5.56.
Okay, what did you get? 5.56 meters per second? Yeah, write it down. Let's move on.
8 point something.
44 divided by
Because he didn't round
You
it.
did 8 point.
He didn't round it to 8.1.
Oh, but sig figs calls for.
So what's the answer?
Right, so we're still. Therefore.
Alright, you guys do this one on your own.
5.57.
Dude,
Double when you plug it in and out.
how about you stop arguing over something that's petty?
But it's very
And
important. But it's
zing!
People often know for buildings.
Weird.
Context is key.
Initial speed.
Okay, set.
Context is key. Judas hanged himself. Go and do likewise. And what you do, do it quickly. All biblical. Context is key. All those verses are in the Bible. They are.
Wait, so change in X.
Context is important, isn't it?
Change in
I know it's not. That doesn't bother me. Everybody should understand what I'm trying to get at here.
Kramer, this makes no sense.
Vx is the change in the.
Okay, then you need to come outside of class.
It's a velocity. Well, no, I'm just kidding. The velocity.
No, Vx is the
It's asking for the
initial
initial
thing.
speed. Is that VI?
Yeah, it's the
Initial.
same.
Oh,
VI
that's
and
right.
VX are the
Yes.
same for.
Yes.
You guys, you're gonna have to know that VI and VX are the same only for projectiles shot straight horizontally, which is what we're doing here. And it should say jumps horizontally. How do you do that? I don't know, but
Having change in X.
run horizontally is what it
That's
should say.
awkward.
Change in X is also displacement, and then now we're also using it for horizontal.
Change in X and VX are different. Different symbols, different meanings, same direction.
But change in X is displacement,
Yep.
and then it's also horizontal.
But when you're,
When you're trying to find, when you're breaking down a displacement vector, you're saying?
No, just in this context,
And
this
John's not
is.
good at time either, but.
I got.
We don't need another.
I got 2.0.
Actually,
That is
Isaac, I got 2.0.
Oh, no, that's.
I didn't look at 60.
That's chicken wine.
What's the?
But still.
This one's
It's the same thing, but it's for a different
Yeah.
thing, and it's.
I think you're looking at it the wrong way.
Oh, I got 2.0.
No.
Don't be heavy, Bryce.
Asking if I can.
No, I was making a joke. I'm just saying 2.0 as well.
Oh, nice. That was good.
Whoa, it's like all. Yeah, so.
Dude, it's like basically Holy Night.
Is that what you got? 2.02?
Is it really? So Stranger Things? I know, that's what I'm saying. It's only like a month and a half away.
I haven't watched
Stranger Things season 2.
And then
Oh,
like
dude.
60 seconds.
And The Walking Dead.
I can watch that.
Yeah, it already came out. Yeah.
I didn't watch it.
Or no, a season got added to Netflix.
Yeah.
Oh, well.
Wait, where?
I don't know when the new season.
You may want these two equations. What? This is essentially the same equation as before, just solve for change in X.
You can do that? I mean, you should times that one. Wouldn't it be divided by 2?
No, it's a reciprocal.
Don't argue with
But you can get.
So I could divide by this, take the reciprocal of everything, and get the other one that I just did.
Oh, what?
I mean,
Projectile horizontally is not bad. Probably easier than what we did a couple days ago. The double vectors.
Which I was here.
That was not.
Because this is technically one, there's really not, yeah, it's just one vector, one direction, and this, we're just following.
It's like what we already did last chapter, just with
is
the.
VX 2.0?
Yes.
Yeah, I guess. When we get into the projectile problems on Monday,
X is 5.0.
then it'll be more challenging. Yes, you may leave it. What was the answer? 2.0?
Yeah.
2.0 meters per second was your initial velocity.
This is
Just if you were solving for
Bible quiz, Bible quiz, Bible quiz.
What?
Hey, you would have want these two equations if you didn't get them in.
Emma, I got it.
Kramer.
Forget, get on a quiz and a test. And
I'll probably do it myself anyways.
I didn't say that, Sassy. I'm just telling you. You asked the question. I told you.
That was pretty sassy.